Alright guys, welcome to Thompson Coding series. In the series we'll be talking about .NET platform, .NET as a software engineering platform. And let's delve in and see what the series is about. However, my name is Dominic Thompson. I am a cloud solutions engineer and a full stack application developer. You can reach me by my email, which is on the screen, or you can check me out on LinkedIn. So the series is not about me, it's about learning. Okay, let's go into what .NET is. What is .NET? We've been hearing .NET. All right, what does .NET means? .NET basically means network enabled technologies. That is the meaning of that abbreviation. .NET is a free cross-platform technology for building applications. So it's open source. You can use .NET to build different types of applications, and you can build a whole bunch of applications using .NET, internet-related applications, desktop application, IoT applications, whatever you dream of building. So many of them can be built using .NET platform. So .NET has been there for a while. It started in 2002 as .NET Framework, and it was Windows specific, means you could only use .NET to build Windows application, only Windows application. So the first version of .NET was called .NET Framework, and it started in 2002. Along the way, .NET came up with another implementation, which is known as .NET Core. .NET Core came into existence in 2014 as a cross-platform and open source implementation of .NET. So eventually, later, Microsoft decided to change the name from .NET Core to just .NET, which means network-enabled technologies for building application. So currently, the current version, as at the time of this video, is .NET 6 LTS. But there is a .NET 7 release candidate 1 already is out, and which is a very fantastic tool for you to use and build your applications. So there is another implementation of .NET known as .NET Standard. .NET Standard allowed the development of libraries and tools that can be shared among the various implementations of the .NET technologies. So what I mean by that is that if you developed a library or a component using .NET Standard, you can use it in both .NET Framework, .NET Core, or even the current version of .NET. Alright, so I already told you what .NET is. Its inception in 2002, and the current version of the framework is 4.8, and Microsoft still maintains it till the time of this recording. We talked about .NET Core, and we talked about .NET Standard, and let's talk more about this .NET, network-enabled technologies. Alright, I've told you before, .NET is free. It's cross-platform. It's open source. It allows you to build various kinds of applications. Now you can build cloud-native applications, console applications, serverless functions in the cloud, web apps, web APIs, and microservices using the .NET platform. You can also build cross-platform client applications such as desktop applications, games, mobile apps using the .NET technologies. You say, like, Dominic, is that possible? Absolutely, very possible. You can use .NET MAUI and a whole bunch of resources as Xamarin to build cross-platform applications in the .NET world. Now, you can build Windows-specific application. Fundamentally, you can build Windows Form application, Windows Presentation Foundation application, UWP application, which the current version of desktop application is .NET MAUI. That is what Microsoft is trying to pull together, and that's what .NET team is trying to put together for use in cross-platform application and Windows desktop application development. So you can use .NET to build Windows services that can do special things. Startup services are the applications that start themselves, or automatically can start and do something on behalf, or run some tasks. Let me use the word run some tasks, and that's more appreciable. So you can build machine learning applications or Internet of Things applications using the .NET platform. The next thing you should understand about .NET is in .NET, applications and libraries are built from source code and a project file. So you have a project file and you can build your applications The project set file is the base point or the foundational point for building .NET applications and libraries. So this can be done using the CLI, or you can do this, you can build applications in the .NET using an integrated development environment like Visual Studio Code, or the .NET CLI, meaning you can build .NET applications from the command prompt. Yeah, you heard me say that, that's correct. Now, what are the various binary distributions of .NET? There's the .NET SDK, which contains a set of tools and libraries and runtimes that allow you to develop, build, and test your applications. And you have the .NET Runtime itself, which contains a set of runtimes and libraries for running your applications. And basically, these are the basic binary distributions for the .NET platform. The .NET SDK contains a set of libraries and tools that allow developers to create .NET applications. I already say that. And the CLI is a component of the .NET SDK. The runtime is also part of the SDK, and the .NET driver, which is the CLI command structure for either running a framework-dependent app or executing a command in the .NET ecosystem. So the next thing we should talk about is the .NET runtime. A runtime is really an execution environment for a managed program, just like we have runtimes for every other framework, Python, Java, Kotlin, every other thing that .NET has its own runtime as well. And the .NET runtime provides an environment called the CLR, Common Language Runtime, that runs the code and provides services that make the development process easier. And the Common Language Runtime is the foundation of all .NET apps. Alright, remember that the CLR is the foundation of all .NET applications. The fundamental features of the CLR include garbage collection, memory safety and type safety, high-level support for programming languages, cross-platform design, and a whole bunch of other stuff there. Now, what do we mean by the managed execution environment? What does that mean? Alright, the managed execution process consists of sequential procedures undertaken by the runtime environment to execute your code. That is what it does. The environment where you run your code is the managed execution environment, and that is what the runtime basically is. So you have a compiler, or you write a language, you code or you build a system in C#, for instance. Compiler translates your language or your code into MSIL. MSIL means Microsoft's intermediate language. So your code is being ported and compiled into MSIL. MSIL code is compiled into machine native code, which is executed in the runtime. All right. So the runtime provides the entire infrastructure that enables execution of your code to take place. And that is what the runtime is. So when you finish building your application using the SDK, you now compile your application into a library or an application. Your source code, you compile your source code into a library or an application, and you host it and you run it on the runtime. All right, that is what the runtime is. So those grammar, we can minimize it, and for you to have an idea, a very good idea what we mean. So basically, you write a code in C#. The C# code is then converted to MSIL. MSIL code is converted to machine code, something a machine can understand, and this code is executed by the CLR. All right, that is basically what I was trying to say. So by now you should know that runtime is what provides the execution environment for you to execute your .NET based source code. So the next thing we will consider is .NET languages. There are a whole bunch of languages there that support .NET programming or .NET software development. And one of them, the predominantly most used .NET programming language, is C#. But that is not the limit. You can use F# and Visual Basic to also build .NET based applications. So C# is a modern programming language. It's object-oriented and type-safe. It has its roots in the C family of language. Those in the C or C++, Java, JavaScript programmer will find themselves comfortable in this language, in C#. And F# is an interoperable language for writing succinct, robust and performant code. F# programming is data-oriented, where code involves transforming data into functions. Visual Basic uses a more verbose syntax that's closer to ordinary human language. It can be easy to understand and to learn for people new to programming. Now, the next thing we will consider is the .NET Package Manager. So, according to Microsoft Docs, the NuGet is the package manager for .NET. Not just according to Microsoft, that's the basic. but it enables developers to share compiled binaries with each other. Nougat.org offers many popular packages from the community. Now, the next thing we will talk about is the deployment model. So according to Microsoft, .NET apps can be published in two different modes. Self-contained applications, including the .NET runtime and the dependent libraries, or framework-dependent applications that require a compatible version of the .NET runtime. .NET apps are launched with a native executable by default, definitely. The executable is both operating system and architecture specific. Apps can also be launched with .NET command. Alright, so these are what you need to understand about the .NET. The next thing, apps can be deployed in containers, so .NET applications can also use Docker containers. Microsoft provides container images for a variety of target environments, and that is the beautiful thing about .NET. Alright, so what is the .NET assembly? .NET assembly is basically the end product of your application. So it can be either a .dll file or it can be an exe file. So an assembly is a collection of type and resources that are built to work together and form a logical unit of functionality. Like I earlier said, it can be a DLL or an exe file that contain a collection of APIs that can be called by applications or other assemblies. They may include types such as interfaces, classes, structures, enumerations, and delegates. Assemblies in the project bin folder are sometimes referred to as assemblies. So typically, assemblies are the building blocks of .NET applications. They form the fundamental units of deployment, version control, reuse, activation scoping, and security permissions for .NET-based applications. Fundamentally, an assembly can be built with one or more source code files. That's what you need to understand. So assembly, you have a project, you have a source code, and you build your source code. Your source code is being bundled as an assembly or compiled into an assembly, and that can be a .dll or an exe file. So in Java, for instance, when you have source code, it's being compiled into a .jar file or a .war file or a .er file. So that is the same thing. So the end product is a .dll file, all right, or a .exe file. Now, an assembly has the following features. It can be implemented as a .exe or a .ddl file or a .dll file. It can be shared, it can be loaded into memory only when required, and you can programmatically obtain information about an assembly by using a concept called reflection in the .NET platform. Reflection is not just a concept in .NET, it is applicable to a whole bunch of standard programming languages out there. So it is also here in .NET, you can use that feature to also examine an assembly and check out and even call methods in an assembly. So you can load and inspect an assembly using the metadata load context class, and we can do a whole lot of things with assemblies. So an assembly is a collection of types and resources. And what are types? Types are basically the type system in .NET. So the type you create. So a type is an attribute of data, in bracket instruction, which tells the compiler or interpreter how you intend to use it. A type represents a structural nature of the data which you can process. It can be numeric, alphanumeric, decimal. A type is basically the type system or the things you create in .NET. So in computing, a type is a terminology used to establish the various constructs, structure, and attribute associated with data within a programming language or technology. I actually prefer that definition of a type because it's closely related. So the next thing we should evaluate is what are resources. Sorry, I missed that. So before then, we should talk about data types in programming language. So a type is just the data types that are applicable in a particular programming language and the type system implemented in the programming language. So the next thing we talk about are resources. So a resource is an external file or source code that is an external file a source code has access to or utilizes while executing its instruction. It can be an image file, it can be a document file. So a resource is a non-executable data that is logically deployed in an app. A resource might be displayed in an app as an error message or part of the user interface. So resources can contain data in a number of forms, including strings, images, and persisted objects. Alright, so that is basically the two things you need to understand. We have types and we have resources, and this form the logical unit of functionality which drives the use, or which an assembly is termed or umbrelled, which defines an assembly. Let me start. All right. So the next thing we are talking about is, we've talked about this already, and we've talked about executable. An executable is a computer file that contains an encoded sequence of instructions that the system can execute directly when a user clicks the file. And we talked about a dynamic link library as a library that contains code and data that can be used for other programs. All right, so you can use .NET to build these two types of output. Another definition that I actually like, which is from Luskevich, is that a dynamic link library is a collection of small programs that larger programs can load when needed to complete specific tasks same time. So by the side of the screen here, you can see some libraries that are like payroll.dll, payroll data DL. And you can see some small light shadow applications in the background, and likewise on the left side of the screen you could see some exe files that are typically you download and install. So when you download an application and you want to install it, it's a .exe file. And you can, if you follow along in the rest of my series, you can see how we actually build this type of files using the .NET platform. So the next thing we are going to talk about is the assembly manifest. Every assembly has a manifest. So an assembly manifest is like a table of contents that contain information, definitions about the assemblies. So it contains the identity information of the assembly, the name and version of the assembly, and the reference list of the assembly. So it can contain information about all the assemblies referenced by that particular assembly. So this is an assembly, according to Microsoft's documentation. Every assembly, whether static or dynamic, contains a collection of data that describes how elements in the assembly relate to each other. The assembly manifest contains the assembly metadata. So assembly is just a file or a resource that contains information about an assembly. All right, so we can have a single file assembly or a multiple file assembly manifest. We can also have that. So we can have an assembly that is a single file. We can have a multi-file assembly which contains the manifest must maintain information about all those resources in these files in this assembly. All right, so on the left hand of the screen you can see the different information that is contained in an assembly manifest. You can pause the video, take your time and read through them and understand the purpose of each of these files. So the next thing we're going to talk about is assembly usage. You can use assembly by just actually adding a reference to it. Finish. In the .NET platform, we use assembly by just adding reference to it. Just like in Java, if you're a Java developer, you'll understand what I mean. In Java, we reference a Java file. We add a reference to a Java file by including it in a class path or a build path. And also, if you're using a build system like Maven, you can also do that. So in .NET, that is the same thing. Here we have a CS project file where you can add a reference, or you just add a reference to it. And .NET, the ID, if you're using Visual Studio, will automatically generate a reference script or a reference details in your application project file. So the next thing we're going to talk about are the various .NET project templates. And what is a .NET project template? And you need to know about this. So a .NET project template, it provides ready-to-run projects that make it easy for developers to start with a working set of code. They provide you a prototype that you start building it. So the prototypes for basically templates are just prototypes for web applications, prototypes for Windows applications, prototypes for internet-based applications, libraries. These are just prototypes that are properly structured for you to start building your applications. So the SDK comes with a default set of templates, and you can see them on the right side of the screen. We have a console template for building console applications. You have a whole bunch of templates there, numerous forms of templates in the .NET. And like this is the templates for desktop applications, and you have those for libraries, building libraries in the .NET platform, and that's basically what a template is. The next thing we're going to talk about is most of the .NET coding features. We have asynchronous code in .NET, we have attributes, we have reflection, we have code analyzers, we have delegates and lambdas, we have events, we have exceptions, we have garbage collection, we have generic types. These are all a bunch of coding features that are available in the .NET platform. We have language integrated query, .NET supports parallel programming, .NET supports serialization, support type inference, and has its own type system, and supports unsafe code. All right, so what have we communicated so far? So far, we've talked about the brief knowledge of .NET and its implementation. We've talked about applications that can be developed with .NET. We've talked about .NET usability. We've talked about the .NET binaries, SDK, and the runtime. We've talked about the .NET managed execution process. We've talked about .NET languages, the C#, the F#, the Visual Basic. We've talked about .NET Package Manager, the library manager, the package management tool for .NET, which is NuGet. We talked about the deployment models, self-contained deployment or framework-dependent deployment. We've talked about .NET Assembly. We've talked about .NET Product Template. We've talked about a whole bunch of features, and that's good. So the next thing, check out my next video. So that's a brief summary of what the .NET platform is and what you can do with the .NET platform. And I've highlighted so many of the features, and I hope this video was rewarding. Thank you for listening. Have a wonderful day. All right, bye.